Alright guys, we're going to get into the next unit here. Learning target 1 is to simplify expressions using properties of exponents. This is basically just a lot of rules when you're dealing with exponents. So we're going to go through a couple different rules just with multiplying exponents, taking exponents to exponents, dividing exponents, and having negative exponents. So we're going to go through some of that here today. So if we start, if we have the same base, notice right away that this is equations or expressions, that have the same base. 3 and 3, x and x, 10 and 10, b, 2, 2, tt, 199, 199, pp. Everything's the same, and that's the only time this works. Okay, so then we call that base number the base. Okay, so if we talk about first expanding out these exponents, 3 to the 4th power, and you guys know what powers mean, would just be 3 times 3 times 3 times 3, right? That times 3 times 3 would be 3 squared. So altogether, that's 1, 2, 3, 4, 5, 6, 3. So we could also just write that as 3 to the 6th power. Okay. Same concept here. X cubed would be x times x times x times x to the 5th would be 5x's multiplied by each other. Okay, altogether that's 8x's, so that's 8 or x to the 8th. Okay, over here same thing. 10 cubed would be 10 times 10 times 10. 10 to the 6th would be 10 6 times. And altogether that'd be 10 to the 9th time, because we're taking 10 times itself 9 times. Okay, so I'm sure by now you've caught on. For any same base, non-zero value of b, if we have that base to one number m times that base to one number n, you can just add those two exponents. If you're multiplying the same base number to two different exponents, it's just those two exponents added together. So here, 2 to the 7th times 2 to the 2nd is 2 to the 9th. Okay, t to the 1st times t to the 28th is t to the 29th. 199 to the 3rd power times 199 to the 9th power is going to be 199 to the 12th power. Okay, go ahead and try that p to the 8th times p to the 22nd. All right, moving on. Now, if we have a power or an exponent to an exponent, let's rewrite these and see how that works out. Okay, so let's start in the parentheses. In the parentheses, we have 4 to the 5th power. So that's 4 times 4 times 4 times 4 times 4. That quantity is going to be squared. Okay, so that means we have 4 to the 5th power. We have those 5 4s. We have them once times themselves again. Okay, so if we're taking those 5 4s and we're squaring it, so we're taking the 5 4s times the 5 4s. All right, so all together now we have 5, 6, 7, 8, 9, 10 4s. So 4 to the 10th power would be that. Here we have x cubed, so x times x times x to the 4th power. All right, so that's taking this x cubes 1, 2, 3, 4 times, because we're taking this to the 4th. All right, so if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's, that's x to the 12th power. Okay, and then finally here we have the quantity xy cubed. So that's xy times xy times xy. All right, so we could rewrite that as x times x times x times y times y times y, because multiplication is commutative. It doesn't matter what order we do it in. That's going to be x cubed y cubed. And that's the same thing as thinking of this as x to the 1st, y to the 1st to the 3rd. All right, and if you can see here, we've kind of already gathered 2 times 5 is 10, 3 times 4 is 12, 1 times 3 is 3. So anytime you have a base number to an exponent to a higher exponent outside parentheses, you take those two exponents and multiply them together. In the same way, if you have two base numbers to an exponent, imagine that they're both 1, and then that just becomes a to the n times b to the n. All right, so let's practice down here. X squared to the 4th power would be x to the 8th. 3x squared would be 3 squared times x squared, using this property here, or 9x squared, because 3 squared is 9. Okay? 2x squared to the 3rd power. All right, well, I know that 2 is just being taken to the 3rd power because this is 2 to the 1st, so 2, that would be 2 to the 3rd, and then x to the 2nd to the 3rd power is going to be x to the 6th. So 2 cubed is 27, x to the 6th. All right, why don't you go ahead and try 5t to the 5th squared. All right, our next investigation is dealing with division of exponents. So let's go ahead and write these out in expanded form. 5 to the 9th would be 5 times 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 5. That's 1, 2, 3, 4, 5, 6, 7, 8, 9 5s, all over 5 to the 6th power. Okay, so what happens when we divide exponents is, you guys know anything divided by itself is just 1, so we do a lot of canceling in division. So we can cancel this. 5 divided by 5 is 1, 5 divided by 5 is 1. We can do that, looks like 6 times. And then we're left with this 5 times 5 times 5 over down here would just be 1. So that's just going to be 5 to the 3rd power. Okay, if we expand this over here, 3 cubed is 1, 2, 3 3s, and 5 cubed is 1, 2, 3 5s, all with multiplication in between them. And then we have that over 3 times 5 squared, so 5 times 5. Again, by process of elimination, we can cross off a set of 3s and 2 sets of 5s, and we have 2 3s left, so that would be 3 squared, and 1 5 left, times 5. All over this denominator would be 1. All right, let's do one more in expanded form. 4 to the 4th would be 1, 2, 3, 4 4s, all with multiplication in between them. And x to the 6th would be 1, 2, 3, 4, 5, 6 x's, all with multiplication in between them, over 4 squared, so 4 times 4, and x to the 3rd, so 1, 2, 3 x's. Cross off 2 4s, cross off 1, 2, 3 x's, and we have 4 squared times x to the 3rd. Okay, so if you might have caught on now, the trick for this one is when we have the top exponent, we can just take that top exponent minus the bottom exponent, because we ended up canceling off however many were in the bottom. Okay, and then we were left with the difference. So 9 minus 6 is 3. 3 minus 1 is 2. 3 minus 2 is 1. 4 minus 2 is 2. 6 minus 3 is 3. Okay, so let's write this one out in expanded form. We have 6x to the 9th over x to the 5x to the 4th. We can't cancel out that 5 and that 6, so this is going to be 6/5 or 6/5 times x to the 5th, or if you'd like to write it with that x in the numerator, 6x to the 5th over 5. Because all we do is take 9 minus 4. Okay. Over here, we have to do some work up here before we can do this. We know that when we have these things multiplied, that's going to be 3 times 8 times x squared times x to the 4th. And we've already learned that that's adding of exponents. Okay, so that's going to be 24x to the 6th. So we have 24x to the 6th power over negative 4x to the 3rd. Okay, when we have these whole numbers, we can go ahead and do this division. So 24 divided by negative 4 is going to be negative 6. And then x to the 6th divided by x to the 3rd, 6 minus 3 is going to give us x cubed. That's our final answer there. Over here, we have 7.5 divided by 1.5 times 10 to the 8th over 10 to the 3rd. Okay, we're going to learn about this in the next time. These are actually two numbers written in scientific notation. But again, we can treat 10 as a variable or as anything. This is going to be 7.5 divided by 1.5 times 10 to the 8th divided by 10 to the 3rd is going to give us 10 to the 5th. If we actually want to figure out 7.5 divided by 1.5, then that's going to be 5 times 10 to the 5th. Okay, why don't you try this problem? All right, and then the last thing we're going to do is investigate negative and zero exponents. Okay, so let's write out this one here in expanded form. We're going to have 7y's and then that over 2y's. So this is kind of the same thing as before. Cross off 2 of those y's, and how many do we have left? We have y to the 5th. Okay, not a lot different than what we just did. Okay, over here we have 3 squared over 3 to the 4th. This is a little different because now if we cross off top and bottom, our leftovers are on the denominator. Okay, so this would actually be 1 over 3 squared because this is 1, so we still have just a times 1 up here. So 1 over 3 squared. Okay, and we'll leave it at that for now. If we write out this one, we have 7 to the 4th over 7 to the 4th. All of those are going to cancel out. Now let's really think about what all that canceling out means. 7 divided by 7 is what? 1. 7 divided by 7 is 1. 7 divided by 7 is 1. 7 divided by 7 is 1. So our answer here, our simplified version, is just 1. And then finally we have 2 to the 1st power, just one of them, over 2 to the 5th. So 1, 2, 3, 4, 5. Again, we cancel here, and then we have 4 left over, so that's just going to be 1 over 2 to the 4th. Notice that it stays the same. We're still using this property, n minus m. 7 minus 2 is 5. 2 minus 4 is not 2, though. 4 minus 4 is 0, so this must be 0. And 1 minus 5 is not 4. So why are these positive, is my question. Why are these positive 2 and positive 4 when really 1 minus 5 is a negative 4 and 2 minus 4 is a negative 2? It turns out that we can rewrite this problem here as 3 to the negative 2nd power. Okay, that is what this is. And in the same way, this is 2 to the negative 4th. When we have positive exponents in the denominator of a fraction, those are negative exponents in the numerator. Okay, so you can see that down here by these two rules. When b is taken to the negative nth power, that's 1 over b to the nth. If 1 over b to the negative nth would be b to the positive nth. So it's kind of flips, okay? And then finally, anything to the 0 power is 1. And that's hard to think about in terms of just exponents, but really easy if you just think about it as the same thing over the same thing. Okay, this was 7 to the 4th over 7 to the 4th is 7 times 7 times 7 times 7 divided by 7 times 7 times 7 times 7. All of those cancel out. All of them are 1. So any number to the 0th exponent is 1. All right, so let's practice this. Okay, I'm going to just practice using positive exponents. So anything that's negative, I'm going to switch it to a positive. So 7 to the 5th power over 4 to the negative 7th power would just be 7 to the 5th times 4 to the positive 7th. Because if we move that over to the numerator, then the sign changes. Okay. Again here, this would be 25 times x to the positive 8. Because if we move it to the top, the sign changes. This is what we're doing here. We're taking that b to the negative nth and bringing it positive to the numerator. Okay. This one, to write it with positive exponents, if we have a negative exponent on the top, then that's going to be a positive exponent on the bottom. So 5 to the positive 3rd on the bottom. and 2 to the positive 8 on the top. Okay, I'm going to do one more example here, and you can add it anywhere. If we just have 2 to the negative third power, that's going to look like 1 over 2 to the third power. Okay, or if I just have 1 over 6 to the negative fourth power, that's going to just equal 6 to the fourth power. Okay, because of that switch. So go ahead and try this one for class, and then that should be the last one for class.